This is lesson 4.5, compound inequalities for algebra. Compound inequalities are where they take two inequalities and they write them together as a group. So, two inequalities that are joined by the word and or the word or form a compound inequality. You can write the compound inequality x is greater than or equal to -5 and x is less than or equal to 7 as -5 is less than or equal to x, which is less than or equal to 7. So they write it like this, and then what you will have to do is graph both and then you combine them. So you notice where do they overlap, and they overlap in these two places. There's the pink line and the blue line. So they overlap there. So then if you look at the answer is this black line. So that is the graph to this inequality. So, writing a compound inequality. Write compound inequalities that represents each situation and graph the solution. So here's a couple quick little examples. All real numbers that are at least -2 and at most 4. So, at least -2, so it would be n is greater than or equal to -2, and n is at most 4, so that's less than or equal to 4. So then they graph it, and then here is what you get. Today's temperatures will be above 32, but not as high as 40. So it would be greater than 32 and less than 40. So try this one. Write a compound inequality that represents each situation and graph your solution. So, A, all real numbers greater than -2 but less than 9. So, all numbers greater than -2 but less than 9. So then what I'm going to do is I am going to rewrite this. Now, I'm going to start with -2, and if I look at -2, my sign is pointed towards -2. So I'm going to point my sign towards -2, put my x in the middle, and then here you can just write this out like this. So then I draw my graph. So x is greater than -2, so I have an open circle at -2. And x is less than 9, so I have an open circle at 9, and it's everything in between. The books, okay, so letter B. The books were printed between $3.50 and $6 inclusive. So, x is greater than or equal to $3.50 and x is less than or equal to $6. Inclusive means including those numbers. So, if I rewrote this, I would start with $3.50. My sign is pointed towards $3.50, so I have to point it towards $3.50, put x in the middle, and then I have $6. So then I draw my graph, start at $3.50. That is a closed circle, and it's everything greater than $3.50 and less than 6. So it's everything in between. Okay, a solution of a compound inequality joined by the word and is any number that makes both inequalities true. One way you can solve a compound inequality is by writing two inequalities. So, this is a large inequality. So it says, write the compound inequality as two inequalities joined by the word and. So you would have r minus 5. Notice, r minus 5 is in both of these inequalities. I have r minus 5 is greater than -4, and I have r minus 5 is less than or equal to -1. So then what you do is you solve each, and then you get your two answers, and you graph them both on one number line. So let's try. We'll try this first one together, and then you can do the next ones. So I'm going to have 3x, it's open, pointed towards the -6, that's my first equation, and then I have 3x is less than 15. So divide by 3. So I get x is greater than or equal to negative 2. And I get x is less than 5. I'm going to graph my equations. X is greater than or equal to negative 2. So I have a closed circle at negative 2 and it's greater than. But then I need to go to 5, have an open circle, and it's everything in between. So try B and C. Okay, so I have 2x minus 1 is greater than negative 3, and I have 2x minus 1 is less than 7. I'm going to add 1, so that's 2x is greater than negative 2. Add 1 here, so that's 2x is less than 8. And then divide by 2, so x is greater than negative 1, and x is less than 4. So I have an open circle at 4, it's less than, and an open circle at negative 1, and it's greater than, so it's everything in between. Here I have negative 3n plus 1 is greater than 7, and negative 3n plus 1 is less than or equal to 13. So I minus 1, so I get negative 3n is greater than 6. Divide by negative 3, so that is n. I'm going to switch my sign, and negative 2. I'm going to minus 1, so that's negative 3n is less than or equal to 12. Divide by negative 3, so I get n is greater than negative 4. So I go to negative 4, I have a closed circle, and it's everything greater than, and then negative 2, I have an open circle, and it's everything in between. All right, real world problem solving. The acidity of the water in a swimming pool is considered normal if the average of 3 pH readings is between 7.2 and 7.8 inclusive. The first 2 readings for a swimming pool are 7.4 and 7.9. What possible values for the third reading, P, will make the average pH normal? So, let's just look at this step by step. So here's the equation. They put the 2 average numbers on either side of the equation, 7.2 to 7.8. That's what it has to be between. And then in the middle, what they did is they put their first reading was here, 7.4. Their second reading was 7.9. And then their third, we don't know what that is yet. And then they divided by 3 because it's the average. It is the average, so they have to divide by 3. So if you look at this equation, what they did first was they wanted to clear the fraction. They wanted to get rid of this 3. So they multiplied all 3 sides by the denominator. So notice, this is multiplied by 3, this is multiplied by 3, and this is multiplied by 3. These 2 clear off, and you're left with 21.6 is less than or equal to 15.3 plus P, and then that. So then they solve the equation, and they say, for the value of the third reading must be between 6.3 and 8.1. So let's try, just want you to try letter A. Suppose the first 2 readings for the acidity of water in a swimming pool are 7.0 and 7.9. What possible values for the third reading will make the average pH normal? So just try letter A. Okay, so if we go back, we know that 7.2 and 7.8 are okay, so yes, x has to be greater than 7.2 and less than 7.8. So in the middle, our readings are 7.0 and 7.9. 7.0 plus 7.9 plus P divided by 3. So next what you're going to do is multiply all 3 sides by 3. So then you get 3 times 7.2 is 21.6 is less than or equal to, these cancel out, I get 14.9 plus P is less than or equal to 7.8 times 3 is 23.4. Now, if you remember, what you have to do is, like what they did here, is they just subtract 15.3 from all three sides. So instead of making it into two equations, they just subtracted this. Whatever you do to one side, you have to do to all the sides. So then you get 23.4 minus 14.9 is 8.5. And 21.6 minus 14.9 is 6.7. So my reading has to be between 6.7 and 8.5. All right, writing compound inequalities. Write a compound inequality that represents each situation. Graph the solution. So here, all real numbers that are less than -3 or greater than 7. So now if you notice, these are both going in opposite directions. So if you see the word or, usually what it means is you're going to have an open circle and one's going to go this way and one's going to go the other way. So it represents both directions. Discounted fares are available to children 12 and under or to adults at least 60 years of age. So if you are 60 or greater, you get a discounted fare, or if you're 12 or younger, you get a discounted fare. Notice, whoops, here they stopped at 0, obviously. 4, write an inequality that represents all real numbers that are at most -5 or at least 3. Graph your solution. So all real numbers that are at most -5. So that means they have to be less than -5 or at least 3. So that means they need to be greater than 3. So I would have -5, an open circle, and everything less than. And then 3, an open circle, and everything greater than. So, solving a compound inequality containing the word or. If the word or is there, notice that my graph goes in two separate directions. So you do the same thing, essentially. You solve both equations and then you graph. So try this one. Solve the compound inequality, here it is, and graph your solution. Okay, so you need to have two separate graphs. So I'm going to -7, so then I get 2x is greater than -4. I divide by -2, so I'm going to switch my sign and my answer becomes positive. Here I'm going to add 4 to both sides, so then I get 3x is greater than or equal to 9. Divide by 3, so x is greater than or equal to 3. And then when I draw my graph, I would be at 3. I'm going to have a closed circle and it's everything greater than. And then 2, I'm going to have an open circle and it's everything less than. So that's it for your notes.